Let's look at another example of assigning configuration. If for this molecule, obviously the hydrogen is number 4, and then the methyl, compared to any other carbon group, will be the lowest priority, so that gets number 3. And now we want to look at the isopropyl group that's right here. This is isopropyl, or this longer carbon group, the 5-carbon fragment. And at first glance, when we're first learning this, we might say, oh, hey, this is a larger carbon fragment. It should get higher priority. Remember, though, that it's the substituents that are attached to the groups that dictate priority. So let's look at what's attached at each of these carbons, because, of course, at first glance, the two carbons are of equal priority. So on the left side, we have CCH. We have two methyls and the hidden hydrogen. And on the right side, we have CHH. So this carbon here is attached to the carbon and then the two hydrogens that we don't draw. And right away we see the first point of difference, the C versus the H. So that means the isopropyl gets the highest priority. That was number 1. And the larger 5-carbon group gets the second priority. So it's important to note here that branching plays more of a role than simply the number of carbons attached. Okay, so the closer the branches, here the branch is on that carbon, and here the branch is further along the chain. The closer the branches, that's how we win. So the isopropyl gets number 1. So now when we count in a counterclockwise direction, and that of course is S. However, you'll notice, of course, that the hydrogen is on the wedge. It's not on the dash, so we need to switch our assignment to R. So this is an R stereocenter. So we will write R here or wherever we want to designate R. Let's look at another example. And here I have not drawn the hydrogen. Sometimes the first step is to maybe fill in whatever is missing, and that's going to be the hydrogen. And of course that's number 4. The oxygen is number 1. It beats both carbon groups. And here again we have some interesting developments. We have a carbon and a carbon, so maybe they're tied. We have 3 carbons on the right side and only 2 carbons on the left side. Again, we want to establish what they are connected to. So this carbon is part of a double bond. And so it is connected to a carbon and a hydrogen, but we have to have 3 groups that it's connected to, and so it's connected to 2 carbons, or we consider it to be connected to 2 carbons because it has this double bond to the carbon. So it gets 2 carbon connections here, and then the missing hydrogen, so CCH. And on the other side, it's just your standard CH2 group, so CHH. And thus again, this double bonded carbon wins as higher priority, even though there's a longer chain on the right side. So the second priority is the double bond, third priority is the 3-carbon chain, and if we count 1, 2, 3, we get it clockwise. And of course, in this case, our hydrogen is in the correct location. It's on the dash, so we don't have to do any switching or anything. We can just assign this as R. Here is another possibility. This is basically the same molecule. We know that the OH is priority 1, the hydrogen is priority 4, and then now all I've done is add a methyl group and a few extra carbons over here. Now we have carbons, and we need to figure out what they're attached to, and we know that the alkene carbon is CCH, and now this other carbon here is also CCH because I've given it a branch. So we need to go further on down the chain of carbons. So now we have this carbon is connected to 2 hydrogens, but it's also connected to a carbon. We consider one of the double bonds as its third group. Remember that everything has to be connected to 3 things, and so the end of this alkene is considered to be connected to a carbon, a hydrogen, and a hydrogen. And then in this case, we have 3 H's. And in this case, we have a CHH. And so now we might be wondering, well, I have 2 groups, 2 sets of lists. I only have 1 list over here. Well, remember that this carbon was connected to, we considered it to be connected to 2 different carbons because it was doubly bonded. So what we have to do is make a list for that second phantom carbon. So we really have two lists over here, and they're both CHH. Okay, so again, because this carbon has a double bond, we consider it to be connected to two carbons. The double bond counts twice, plus the H that's not drawn in. Thus, when we make our lists for the next carbons out on the chain, we need to make a list for this actual carbon. Because it's a double bond, it gets a bond to the carbon, and it gets the H and the H that are actually on the end of the bond. And then we have to make a list for the phantom carbon that's out here too, because everything has to be, we have to have a list for both of these C's here, just like we have a list for both of these C's. One of them is HHH, the other list is CHH. And thus you can probably tell where the point of difference comes in now. CHH and CHH ties with this one, but it's higher priority than this list. And so still, this alkene gets a higher priority than the branched alkane. And that's because we essentially give two carbons, two lists to the end carbon here, so it counts double, and thus it beats the methyl group that's right here. And so if we count 1, 2, 3, again, this is R, just like the second example today.